Hi, I'm Michael Correa, and this is Psych Exam Review. In this video, I'm going to explain some early approaches to studying the brain. Now, unfortunately, early researchers were fairly limited in how they could study the brain. And the main way that they had to study the brain was just to look at deceased brains. So after someone died, they could open the skull and look at the brain and look for abnormalities in the structure or for damage in the brain. But they didn't really have a way to study living brains. Right? They couldn't open up the skull of a living brain, and if they tried, it probably wouldn't be a living brain much longer. So one of the main techniques for studying living brains was to look at people who had some injury or some damage to the brain, but who survived this injury. So we would look at some particular brain damage, and then the idea was to try to connect this to whatever deficit or changes occurred in the person's behavior. So, for instance, if somebody had some damage to the back of the brain, they had some injury that affected the back of the head, and subsequently they had visual problems, then we could infer that the back of the brain must have something to do with visual processing. Now, one of the most famous examples of studying brain damage and resultant change is a man named Phineas Gage. So Gage was a railroad worker. He was a foreman in Vermont, and in 1848, Gage was working, and what he was doing was they were doing some blasting. So we have some area here where we have some explosive charge, and what Gage was doing was packing sand on top of this explosive material, and he was doing that using this 3-foot long bar called a tamping iron. And unfortunately for Gage, what happened was that the explosive accidentally detonated. And this turned this 3-foot bar here into a projectile. And it projected right into his left cheek and continued clear out the top of his head and landed somewhere over here. And of course, along the way, it took some of his brain with it. And in fact, the part of the brain that it took with it was part of the left frontal lobe, which is the area basically just behind the left forehead here. Okay, so what happened to Gage after this? Well, surprisingly, he didn't die. He survived this accident. In fact, he was able to remain conscious and tell a local doctor what had happened. But he wasn't exactly the same person after this accident, at least according to his friends and some doctors who studied him. So one of the obvious changes was he lost vision in his left eye. It's because the bar passed through the nerve behind the left eyeball, which connects it to the brain. But more importantly, people said that he didn't act the same. Sort of the famous quote here was that he was no longer Gage. His friends say that his personality seemed to have changed as a result of this accident. They said before this he was a hardworking, polite guy, organized, was able to delegate responsibilities well in his job as a foreman, but that after the accident, he wasn't able to do these things, and that he was fitful and profane. He'd have aggressive outbursts and swear and scream at people. And so the idea was that his personality had changed. And this was, remember the time, this is 1848. Around this time, people didn't necessarily think this way, right? You might think of your personality as being your, some part of your soul or some, unchangeable aspect of who you are. But what happened to Gage showed that actually it's probably something that your brain is doing. It's physical processing in the brain. So if you take out that chunk of the brain, then you change who you are. Now, unfortunately, we don't have really clear evidence of exactly how much Gage changed. And part of the reason for this is because the problem with this approach is that we don't have a lot of information about people before their brain damage. Right? Nobody was studying Gage before this happened. The researchers only became interested in him after the brain damage had occurred. So they didn't have lots of clear records about Gage before the accident. And in fact, they didn't even keep really clear records of Gage after the accident. So people studied him immediately after and while he was recovering, but they didn't track him for the rest of his life, at least not very closely. It turns out he moved to Chile, he became a stagecoach driver, and so we don't have a lot of detail on exactly how much he recovered or how his personality may have continued to change over time. We might also think about how much an accident like this would change your personality anyway. If you went from, suddenly losing vision in your left eye and having a big scar on your face and a hole in the top of your head, this might change your interactions with people as well. And it's hard to say how much of that is due to the loss of brain tissue and how much is due to the other aspects of this accident. Nevertheless, Gage remains one of the most famous examples of this approach of studying the physical location of brain damage and subsequent change in the person. Now, not all brain damage is this obvious. In Gage's case, we could look through that hole in his head and see exactly what part of the brain had been damaged, what part was missing. But other brain damage might be a little more subtle. And for instance, we might have internal damage to the brain that we can't really see clearly from the outside. So this here is a blood vessel in the brain, and what can happen is we could have a stroke. So what happens in a stroke is that something obstructs the flow of blood to a particular blood vessel here. And so we have something like a bit of fatty material or something clogs the vessel and stops the flow of blood. And as a result, that means that this area of the brain here that's supplied with blood from this vessel here no longer receives the flow of blood, therefore it doesn't receive oxygen, and so this small section of the brain is going to die. And now we can try to study this relationship between which area of the brain has died, how large of an area, how small, and where was this area, and what were the subsequent changes in the person. And a famous example of this type of study of internal brain damage and changes in function is from a French physician named Paul Broca. And around 1860, Broca studied a patient named Louis-Victor Leborgne. And what happened to Leborgne is he had problems with language production. In fact, most people referred to him as Tan. The reason they called this patient Tan is because the only syllable that Leborgne could produce was the sound tan. So he had had some internal brain damage. It's unclear whether this was from a stroke or he had had some seizures previously. But Broca studied Tan, and eventually Tan died. And Broca became interested in the relationship between the specific language problem that Tan had, only being able to produce the syllable tan, and the damage that might have occurred to his brain. So Broca performed an autopsy on Tan after he died. And what Broca found, this is a brain here. Let's say this person is facing this direction. So this is the cerebellum in the back, the brain stem, and this would be the left side of the brain. This would be the front, this would be the back over here. And what Broca found in Tan was that Tan had some damage to his brain around here in the left frontal lobe near the border of the temporal lobe. And so Broca surmised that the specific language problem that Tan had, which is called aphasia, it's a type of aphasia, this difficulty in producing speech, was connected to this area of the brain. And so Broca studied other patients who also had this type of aphasia, and then when they died, he looked at their brain and he found that they also had damage to this area, usually from a stroke. And once he had found several cases of this, he became convinced that this area of the brain must have something to do with this type of speech production problem. And in fact, we now call this area of the brain Broca's area, and this particular type of speech problem, difficulty producing speech, is now called Broca's aphasia. And with modern methods and scanning and imaging technologies, we can see that this area of the brain seems to do something related to coordinating the muscle movements that allow us to produce speech. Okay, in the next video, we'll look at these modern techniques of scanning and imaging the brain, but we're still going to follow this same general principle, which is that we look for areas of brain damage or areas of brain functioning, and we try to connect those to specific deficits or to specific aspects of behavior. I hope you found this helpful. If so, please like the video and subscribe to the channel for more. Thanks for watching.